Hey there, welcome to my video on Zeek clustering. My name is Keith Jones. So this is going to be one of the more advanced videos that I've done on Zeek because clustering is not a trivial topic by any means. Why do you cluster with Zeek? Well, if you're just running Zeek on PCAPs, you're not clustering. If you're running Zeek on live network data with network interfaces, then you are clustering. There's three main pieces to Zeek when it's clustering. The first is the manager, and there's usually one manager that oversees the whole operation. There is the proxies, which don't actually see any data from the network interfaces, but they're processes that are available for computation if you want to use them. And then there are the workers, and the workers then see either network interfaces or portion of network interfaces, and that's where it takes the network traffic and starts applying the Zeek logic to it. Now let's assume for a second you want to develop a scanner, and this scanner's got to know, okay, let's say it's a rudimentary scanner. Let's just say you got to see two attempts, two different types of CVE attempts across the wire from a particular IP address, and then you'll say, oh, that thing is probably a scanner. So just go with me on this for a second. So if you imagine in the network, like the live network data sense, the non-PCAP sense, you've got all these processes running that I'm showing you on this slide, and one worker could see the CVE A from this IP address C, and then another completely different worker could see CVE B from the IP address C. Separately, they're bad because it's CVE exploits, but barring that for a second, separately they don't mean much, but when you put them together, it could give you more information. You could say, oh, maybe that's a scanner. To do that, to put that information together, you basically have got, you see, we have two different workers involved now. So if you were to store the data in a Zeek container, like a set, for instance, it's only going to be on that process. It's not going to be on any of the other processes. Okay, so when we're clustering, we got to get data from the right workers to the right processes for the logic that we're trying to execute with Zeek. All right, hope you follow me with that. So why do I cluster? Two main reasons. The first one is usually the first biggest reason why I cluster, and then the second one is usually just a benefit to other things that I've got to do when I'm clustering. So usually the number one reason why I cluster is to save the same set of data on predictable known Zeek processes. So that way I know if it's an IP address of something, it's going to be on this process. If it's IP address something different, it's going to be on that process. Now, another thing you're able to do when you cluster is that you can reduce processing on workers. So the workers are going to be looking at the data going across the wire. You want them to be as fast as possible. So if there's any type of processing that has to happen on the data other than maybe just logging, you might want to pass it to a proxy and let the proxy execute much longer on that data and let the workers get back to doing, to looking at the live data on the fly. So there's different methods you can use to send data around. So assuming most of the time you're going to be on a worker with some data and you want to do something with that data. You either want to send it like to a manager, or you want to send it to a proxy, or you want to send it to a worker, or you might want to send it to a subset of those. And to do that, to move that data around from the worker of where it sees it on the network to somewhere else, you can use different methodologies. So I'm going to show you, it's basically straight out of the Zeek documentation. I'm going to show you the different methods you can use to move data around these different nodes in the cluster. So the first way is sending from workers to the manager. Now, this is where I'm showing you the green arrows, where it's basically, let's say you see the CVEs, exploits go across the wire, and you want to store it someplace that it's all kind of combined. So that way later on you can do, maybe some processing on it or alerting on it or something like that. So you can see in this picture, what we have is workers are sending up, and I know my hand are exactly opposite because of the camera. I guess it'd be that way on the slide. But it's sending it up to the manager, and then basically the manager would save it in some type of container. So that's one method here. That's if you want to basically process on the manager. If you want to process on the proxies, what you do is you take the information from the worker and then you ship it from the worker directly over to the proxies. A little more difficult because usually we run one manager, but we run 2, 3, or more proxies. And all the proxies are just processes that are there available to compute on the data that you give it. Now, in another situation, you might want to take the data that you have and then somehow get that data to other workers that aren't you. So to do this, you actually have to bounce it either through the manager or through a proxy. So that's why you see the double-ended arrows, the green arrows, and there's two methodologies you could use. You could send it through the manager. I typically like to use proxies because I found people use proxies less, so I usually try to use proxies since they're more available. So I'm just showing you there's two different methodologies depending on which one you use on that slide. It either goes through the manager back to the workers, or it goes through the proxies back to the workers. Now I've waved my hands a lot, and I have like some vague green arrows. At this point, let me show you the functions that we use to send this data around to different places that I just showed you on my slides. So there's three different methods, basically, three different functions which represent three different methods of sending the data around. And all three of them are publishing methods. The first one is kind of the simplest. It's just the broker publish method. And you can use this when you're sending to one process. Like for instance, if you're sending to the manager, you could just broker publish to the manager. Or you can use it to send to everybody in a group. So you could send it to like all the workers or all the proxies. The second one is round robin. So when you have groups like the proxies and workers, there's more than one process in that group. So there's two different ways you can send data to those processes. You can either send it as round robin, meaning you don't really care about a particular key and you don't really care where your data lands. You just kind of want to spread it out amongst all of them in a round robin fashion. So that way everybody gets a little bit of processing time and things just, go faster. That's one methodology, and that's the second bullet there. So there's two ways you can do it. I'm going to show you an example in the slide coming up using the first RR topic and publish, which actually comes straight out of the documentation. But there's also this other function called the ::publish RR. And I know I don't have the colon in there. Let me go ahead and add that. So the : :publish RR. And what that does is it kind of combines the two functions that I showed you with the RR topic and the publish. It puts it all into one. And the publish _RR is a lot like the one that's just below it, which is the publish hashed. So what is this? So there are times where you're going to want to take data and know what node it lands on out of a group. For instance, you might have data that belongs to an IP address. So you can hash that IP address, and based upon that hash, Zeek will know which node to send it to. And it's always going to send the same data from that hash to the same node, which makes it really convenient. Quick tangent. Everything you see in blue on here is clickable. All the like broker publish and so forth. That all goes to the documentation. I'm going to put the links of this in the description of this video so you can just watch it. And then later on, you can go to the documentation. So don't worry about taking notes and all that kind of stuff. I've got it all linked for you. So with those three methodologies, we can basically move data around the nodes. We can either publish it, we can publish it round robin, or we can publish it using a hash. And again, the hash is just some value. And even if it's you think, oh, I can't hash this or that because it's a complex value, you can just make it a string. And you can always hash a string and use that as the value that you're going to use to pass your data around. Now, I do have the two links to the Zeek documentation there at the bottom of this slide as well, if you want to just go to the general sections. All right, so let us look at an example. I published a video recently, and I'm going to link it now. And it was called Using Zeek Signatures to Detect CVEs. And there's the link also in the slides. And in this video, I tried to give you a real quick explanation of the clustering logic in there. And I try not to get into the weeds of it. And I probably did a pretty terrible job of it. So that is part of the reason why I'm making this video. So now let's go back and look at that video's content in this context of clustering, and let's look at just the clustering areas in particular, so that way we really understand what it was or what is in that source code. Now, the source code does look a little different between that video and this video, and that's because when I went through and I saw the clustering, I was like, this clustering code doesn't work exactly how I want it to work, at least to explain it. So I rewrote parts of it, and so the code looks a little different, but I think it's going to get across the same methodology that I talked about in my prior video. So everything up through 9 isn't really anything we need to worry about. It's just the module exports and saying we have this event called toWorkerSet that takes an address. Line 11 is our set endpoints, and if you watch that prior video, the CVE worked when there was a port map set and then a dump. So what we need to do is record the information about what address is set, and then, or what the response address, what sets happen to. Because when we look at dumps, we need to go back and say, did a set happen previously? And if it did, then we're going to fire a notice. So the clustering code comes into, well, basically line 13 on down. And this isn't all the code. I have another slide, a couple other slides coming up. So let me start at the bottom for a reason. I'll start at line 19. This will execute on all the proxies, and I'll show you why in the next slide. So hang with me in a second. But basically, this is an event called toWorkerSet. And what it does is in line 22 is it takes the data that it receives, address, and I just call it resp-h. So it takes this address and sends it to the workers. Okay. Now, how does this work? Line 22 says broker publish. It was one of those publish functions that we talked about in the prior slide. Cluster : worker topic says, so if you put that together with the publish, it says publish to all the workers. The next argument says set endpoint. So it says the event sent endpoint. So on all the workers, the event set endpoint is going to run, and its argument is going to be the next argument, which is resp-h. Okay. So now I can go up to line 13 through 17, which is the set endpoint. And all it does is take this address and put it into the set for you. Now, I'm using set a couple different ways here. There's the set in the port mapper sense, and then there's the set in the container sense. So we're marking the fact that we saw a set in the port mapper sense in a set container. Okay. Now, if we go to the next slide, this is just a few more lines down. Don't really worry about lines 26 through 30. This is basically just doing an if statement around versions of Zeek. Because of the ampersand is used there, cause some issues. So this is a function that's run when the set signature fires. That's what you see on the slide. So line 32 is basically an if-else statement where it says if it's a cluster, run lines 33 through 34. If it's not, run line 36. So if it's not, it's simple. We're just taking our resp h, or our responding host, and we're putting it in our set endpoints set. Now, if it's a cluster and lines 33 and 34 are run, this is a little different. So what happens is line 33 generates this thing. I call it a PT as proxy topic, I believe. And I think I stole a lot of this right out of the Zeek documentation on how to do clustering. Remember those links earlier? I think I stole them right out of these two lines. I believe I stole straight out of those links for the example. So what it does is it sets up the proxy round robin topic. So that's the variable PT. And you can see that because it's RR topic. So that says round robin topic. That's the function you're calling. It's being called on the proxy pool. So that's all the proxies. And then the name, and I'm not exactly sure why there's a name in here, but it needs a name. I just gave it the CVE to be different, unique than any other package out there. So that's why that string's there. Now line 34 actually does the publish. So it does the broker publish. The PT says round robin on the proxies. And on those proxies, it runs the two worker set event, which I showed you earlier, the last slide. And it gives it the resp h variable. So if we can tie this together, lines 33 and 34 ends up calling line 20 through 23 here. I just went back a slide, which ends up calling line 14 through 17. But where these places are called are different spots. At first, on this slide, this happens on a worker that's reading it off our network interface. Here, line 20 through 23 happens on a proxy. And then that proxy then fires it off on all the workers again on lines 14 through 17. Okay, I'll say that again. This slide runs where the network data is being captured and analyzed first and foremost on a worker. Lines 20 through 23 here, that runs on a proxy. And what that does is on the proxy, it then sends it back to the workers with event 14 through 17. And all that does is it adds this address to the set on the right, on all the workers. So that way, now I'm going to go to the next slide here. So that way, when the dump signature fires with line 48, we can then test whether or not that address was used with the set prior to this point. If it is, then we execute lines 49 through 51, which is just a standard Zeek notice that says, hey, a port map RPC set with a port map dump was seen, and that could be this CVE. You might want to look into it. Okay, I hope you follow me with that. Now, one of the things I didn't talk about was publishing with the hash. And I tried to find a good public example that we have of that, and I couldn't find a good one. So I actually just went to the documentation. The documentation's great. So under the workers sending information to the proxies, there's this source code snippet that illustrates how to use this hashing that I talked about earlier. So up at the top event there's an event called worker to proxies, and this, all it does is basically prints out what comes in. just to let you know, this is an example, just to let you know, hey, I got some data to show you the whole pipeline works. The next global down called my counter, this is just used for our hashing value. Now, this event at the bottom called some event handled on worker, imagine this is like some a DNS event or HTTP event or something along those lines that'll be on a worker. And what it would do is then publish the data based upon a key that gets hashed over to a specific proxy that's dependent on that hash. So that gets done with the cluster : publish HRW function. And what that does is, you can see in this example, it says send to the proxy pool. The next thing is the key. So in this case, it cats a bunch of things together and makes a string, and Zeek will then hash that string. So in this case, it hashes example key with my counter. And that's the key. Now, the next argument is what event fires on that proxy that's keyed by that hash. Well, in this example, it's just worker to proxies. Okay, it's just that kind of dummy function that we showed you up front. And the next argument is the argument into that event worker to proxies. In this case, we're just going to send it the cluster node. And you can see it kind of bubbles down all the way through the print up there at the top. So if you're dealing with hashes, this is the general framework you use to go about that. And why I use hashing is when I need to save. In the prior example, we sent addresses to be saved across all the workers. That uses a lot of memory. In this case, our set had an expire on it, a write expire of 3 minutes. So it eventually, it'll disappear. What I typically do with hashes is I use them to send data to specific processes, so that way I don't have a bunch of copies of memory all over the place. Because you want to be neat and tidy, and you don't want to use up too much memory, saving the same address across all the different workers. So maybe we want to save more complex information about different addresses, but we'll use that address as that key to send over to a proxy, and then we'll save that more lengthy information over on the proxy rather than sending it to all the workers or all the proxies, for instance. And that's why you would use hashing, and that's why I use hashing in most of my work. Hey, that's it. If you have any questions, feel free to drop me a comment here on the video and I'll answer it. And I hope to see you on the next video. Thanks. Bye.